Hello students. Now in today's session I will explain question number 2 and question number 3 of exercise 6.1. So in question number 2 we have 3 sums. So let us do the first one. So in question number 2 we have to draw some rough sketches. So get prepared with your pencil, scale and rubber. Now let's see what we have in sum number A of question number 2. So in sum number A, we have to draw a median. That is, in triangle ABC, BE is a median we have to draw. Fine. So in triangle ABC, what we have to draw, students? BE is a median we have to draw. Fine. So BE is a median. Now let's draw the figure. So this is the figure, students. First of all, we will draw one triangle. Okay, and then we'll write all the dimensions. That is all. We will name the vertex, that is A, B and C. Okay, and now what we have to draw? We have to draw a median, that is BE. As it is given BE, so we have to draw the median from vertex B to the side AC. Fine. So what is median? Median is a line which is drawn from a vertex to the opposite side, and it should meet with the midpoint of the opposite side. So the first thing what we'll do, so if we draw any line from point B, students, from here, so the line should join the midpoint of AC, isn't it? So first of all, we'll let this point E as a midpoint of AC. So AE and CE would be equal. So now we'll join this BE line. Sorry, just a minute. We'll join this BE. So this is your median, students. Okay. So this is the required drawing of sum number A. I hope all of you have understood. Again, I am repeating, we have to draw a triangle ABC. See, I have drawn a triangle with a red color. After that, you have to name all the vertex, that is A, B and C. After that, you have to mark a midpoint of AC, and that will be considered as E. Okay, because we have to draw a BE as a median, so E should be the midpoint of AC, and the vertex would be drawn from vertex B, because the name of the median is BE. So from B you have to draw one median towards AC, towards the side AC, and if you are drawing any median from any vertex, the line should meet the midpoint of the opposite side. So this is what exactly we have done. From B we have drawn a line, and this line is meeting a point E, and E is a midpoint of AC. Okay, so it's very, very easy. Now let's move on to sum number B. Now what we have in sum number B, students? In sum number B, what we have to draw in triangle PQR. In triangle PQR, P and R are altitude. PQ and PR are altitude. We have to draw altitude this time, that is 90-degree line. So PQ and PR are altitude of the triangle. Okay, so this is what we have to draw in sum number B. Now how to draw this? So we'll draw a right angle triangle for this, students. Okay, so let me show you one right angle triangle. Here, it is a right angle triangle. Now if we draw, see, this is a right angle triangle. This is a 90 degree. Now what we have to draw? We have to draw PQ and PR. So you see, in both the cases P is common. P is common. So we'll write P here. Okay, P here. Okay, and what is the name of the triangle? PQR. So we'll write PQR like this, PQ and R. Now if you draw this figure in this way, we'll observe that PQ is also perpendicular. Now if you see in this way, suppose, so PQ, this is PQ, you see PQ. So PQ is 90 degree on the side PR, isn't it? And if you see PR, PR is also 90 degree. See, PR is also 90 degree on the side PQ. So in both the ways, these two lines, that is PQ and PR, are altitude of a triangle PQR. Fine. So this is the required figure, students. Now let's move on to sum number C. Now what we have in sum number C? In sum number C, we have to, in a triangle, okay, we have to draw one triangle first. In triangle X, Y, Z, X, Y and Z, what we have to draw? YL is an altitude. Okay, is an altitude in the exterior angle. In the exterior of the triangle. So the altitude will be not inside the triangle, but it has to be outside the triangle, and we have to draw one altitude, not median. So exterior of the triangle. Now how to draw the triangle so that the altitude would be outside the figure? So in that case we have to draw an obtuse angle triangle. Fine. So let me just show you the triangle. Suppose this is a base and this is a triangle. This is another line. This is an obtuse angle. Okay, obtuse more than 90. Then we'll join this line. Fine. So this is an obtuse angle triangle. Now in case of obtuse angle triangle, the height is always outside. So we'll extend this line, students. Okay, we'll extend the base towards left hand side. That means towards this side. See, towards this side we'll extend it. Okay, and now we'll draw the height. So height will be this. You see. So this height, this is an altitude 90 degree. So this is the height of the required triangle X, Y, Z. X, just a minute. X, Y and Z. So this is a required triangle XYZ, and XYZ is a obtuse angle triangle, and in case of obtuse angle triangle, students, the height is always outside the figure, and this is a required height, and we'll name this height as L. Name it as ZL. So ZL is an altitude. Of a triangle X, Y, Z. Okay, students. So this is a required figure. Please draw it very, very neatly. Okay. Now let's move on to sum number 3, and let's see what we have in sum number C. It's very interesting question. So in sum number 3 we have verify by drawing a diagram. Okay, again we have to draw a diagram, and we have to also verify what? If the median and altitude of an isosceles triangle can be same. So they are saying that if it is possible that in an isosceles triangle the median and the altitude can be same thing, or can be of will be a same line. So let's show, yes, it is possible. So let's see how it is possible. So first of all, we have to draw one isosceles triangle. So this is an isosceles triangle. So in isosceles triangle, what is the property? The property is these two sides will be equals to each other, isn't it? Any two arms are equal, so we'll consider these two arms are equal to each other. Now let us draw one perpendicular. Now first of all, we'll name this triangle. So what is the name of this triangle? We'll let this as A, B and C. A, B and C. Okay, now we'll draw one perpendicular. So if we draw one perpendicular, just a minute, from vertex A, so it will look like this. Okay, so it will look like this. So we'll consider this as 90 degree. So AD is perpendicular to BC. So we'll name this as D. Okay, so AD is perpendicular to BC, isn't it? Now it is an altitude of the triangle. So now it can be also observed. Now what we can observe is that BD, just with the figure, from the figure we can observe that BD, this length BD and DC, they both are equal. They both are equal, students. Okay, so as you see, once we have drawn this AD as a perpendicular, then what we can observe that the length of BD and DC are equal. So if BD and DC are equal, that means D is a midpoint. Fine, so D is a midpoint. So a line which is drawn from a vertex to the opposite side, on the midpoint of the opposite side, so that would be a median also. So now what we have to write? So we can write it as, it can be observed that the length of BD and DC is also same. So the last line, what we can say, therefore, we'll go to the next page. Therefore AD is also a median. Median, because as we know that median is a line which is drawn from a vertex to the opposite side to a midpoint of the opposite side, isn't it? So this is what exactly happening. See, we are drawing a line from a vertex A to a midpoint of D. Why D is a midpoint? As we have already observed that BD is equals to DC, so D would be a midpoint. So when a line drawn from an opposite vertex to a midpoint of the opposite side, so that line will be considered as what? Median. And AD is also a median, and AD is also an altitude. So this is what we have written. So AD is also a median of this triangle. So it is shown that median and altitude of an isosceles triangles are both same thing. Okay, I hope all of you have understood this. Fine, so that's it for today's session. Thank you all of you. Take care and stay blessed.